Hi all. So in last class we discussed about physical quantity and derived quantity, and we have discussed how we can derive different quantities from physical quantity, right? Then we discussed about different kinds of system of units like SI system, MK system, FPS system, CGS system. Now in today discussion we will going to study about conversion of unit from one system to another system. Then we will understand how we can represent any physical quantity by its dimension, and then we will understand what is the use of dimension. Okay, so let's start. Yeah, so the first discussion of today topic will be conversion from one system to another. See, first we will understand from SI system to CGS system. So let's consider a very basic question, a very basic example. For example, SI unit of force is what? Newton, right? And we know that force equal to what? Mass into acceleration. So Newton is nothing but SI unit of mass is kg, and for acceleration it will be meter per second square, that means meter second to the power minus 2. This is what we called Newton, right? Now if we have to change this system into CGS system, how we can do this? See, kg equal to 1000 gram, right? And 1 meter equal to how much? 100 centimeter. So from here we can write it as kg meter per second square equal to 1000 into 100 by second square. That will be the same, right? This will be gram and this will be centimeter. So from here we can write it as 1000 into 100. So this will be 10 to the power 5. That's why we say 1 Newton equal to 10 to the power 5 gram centimeter per second square. And this is what we call dyne, 10 to the power 5 dyne. So 1 Newton equal to 10 to the power 5 dyne. This will be the S unit of force in CGS unit, dyne. So if we have to, if someone asks you what is dyne, so you will say that 1 Newton equal to 10 to the power 5 dyne, right? Now let's understand how we can change. You know that SI unit of energy is joule, right? So now we have to change this into CGS system, right? So let's understand. Kinetic energy equal to what? Half mva square. And we can represent any kind of energy in joule, right? In joule. So from here you can say that joule equal to what? mass, that means kg, into v square, that means velocity square, that means meter square, and per second square to the power 2, right? Meter per second square, sorry, meter square per second square. So this will be kg meter square s to the power minus 2, right? Now we can write it as 1000 gram into meter square, that means 100 centimeter square, and second to the power minus 2. This will be equal to 1000, that means 10 to the power 3 into 100 to the power 2, that means 10,000, right? So we can write it as 10 to the power 4. So it becomes 10 to the power 7. 10 to the power 7 gram centimeter square per second square, right? So this is called what? 10 to the power 7 erg. So we can say that 1 joule equal to 10 to the power 7 erg. So erg is the unit of, energy in CGS system. So in this way you can change from, any system to another system. You just have to, you just have to know the basic things like how much equal to how much gram, how much meter equal to how much centimeter, these things you just need to have this basic knowledge, then you can easily convert from one system to another system. That's all about unit conversion. Okay, so now we will understand about dimension. What is dimension? So in previous class we have discussed that in previous class we discussed about, physical quantity. So in physical quantity I had told you that any quantity which can be measured, right, which can be measured by any instrument is called physical quantity. Then we further classified physical quantity into two quantities, right, that is fundamental quantity and derived quantity. And you know that there are 7 fundamental quantity and rest are derived quantity. So 7 fundamental quantities are mass, length, temperature, or current, amount of substance. uh, these are, fundamental quantities. Then speed, velocity, torque, viscosity, all these are derived quantity. Why it is derived quantity? Because it is derived from any another quantity. And fundamental quantities are those which are not dependent on any another quantity, they are independent, right? So now let's understand what is dimension. Dimension. So dimension is what? Dimension is nothing but is the way to represent any physical quantity. It is the way to represent any physical quantity. So how we can define, dimension? So we can define dimension as dimension hold on. Hold on for a moment. Just hold on for a moment. Yeah, now it's okay. So dimension is what? It is, how we can define dimension? Dimension is nothing but it is the way to represent any physical quantity, any physical quantity to which the fundamental quantities, the fundamental quantities must be raised, must be raised right. So this is the definition of dimension. Dimension is nothing but it is the way to represent any physical quantity. So now let's understand how we can represent fundamental quantity by its dimension, or generally dimension of fundamental quantity. So the first is mass. Mass can be represented as square bracket capital M. This is the dimension of mass. Then we have length. Length can be represented as square bracket capital L. Then we have temperature. Temperature can be represented as square bracket capital K. Then we have current. Current can be represented as square bracket A. Then we have amount of substance. Amount of substance. This can be represented as square bracket mole. Then we have time. Time can be represented as square bracket capital T. So this is the dimension of fundamental quantity, right? Now we will understand that how we can calculate dimension of any derived quantity, right? So you know that derived quantity is what? Those quantity which is derived from any fundamental quantity or other quantities, right? That are called derived quantities. So now we will know that how we can calculate the dimension of any derived quantity. Okay, so now let's start with velocity. Velocity is what? Displacement d upon time. So displacement is what? Displacement is nothing but length L and time is t. So the dimension of velocity will be L upon t. So we can write it as L t to the power minus 1. This will be the dimension of velocity, right? Now acceleration. Acceleration is what? Change in velocity per unit time, right? That is, velocity is what? L t to the power minus 1 upon time, that is t to the power 1. So this becomes L t to the power minus 2, right? This will be the dimension of acceleration. Now Force. Force is what? Mass into acceleration. See, you can find dimension of any quantity by its formula as well, and there is other way as well. Like if you know the unit, mass is what? Kg, and acceleration is what? Meter per second square. So from unit it is easy to find, dimension. Kg is what? Kg is mass, that is m. Then meter is what? Length L upon s square, that means t square, right? And this will be equal to m L t to the power minus 2. So here you can see that from unit it is easy to find dimension. So there is two way. Either you can calculate by its formula or by its unit. But for me, I generally find that from unit it is easy to calculate dimension. Okay, so you can apply this. Now let's consider another example, energy. Energy. You can consider any kind of energy. So here I am considering about kinetic energy, that is half mv square. So m is what? Mass, that means m, and v is what? Velocity, that means L t to the power minus 1 to the power 2. So this becomes m L to the power 2 t to the power minus 2. This will be the dimension of energy, right? So this way you can calculate, dimension of any physical quantity, any. Suppose you have to calculate dimension of impulse. Impulse. How you can calculate? Impulse is what? Change in momentum, right? So we can say that impulse is force into time. And force is what? Mass into acceleration ma into time t. So from here it will be mass, that is m, acceleration, that is L t to the power minus 2 into t's time, that means t. So this becomes m L t to the power minus 2 plus 1, that means t to the power minus 1. So this becomes the dimension of, impulse, ml t to the power minus 1. So this way you can calculate dimension of any physical quantity, any. Okay, so now let's consider some other examples. If we have to calculate dimension of gravitational constant, find dimension of gravitational constant. So what is gravitational constant? So for that reason you need to understand F equal to G m1 m2 upon r square. This is the gravitational force between any two celestial bodies. So from here we can say that capital G, that is gravitational constant, equal to force into r square upon m1 into m2, right? So force is what? M A. Force equal to mass into acceleration, that means m L t to the power minus 2, right? Then we have r square, that means length square, that is why it will be L square, upon m1 into m2, that is mass, that means m square. So from here we can write it as m. See here m to the power 1 and नीचे क्या है m to the power 2, right? So from here you can write it as m to the power minus 1 L to the power 3. How? This is 1 and this is 2. So this will be 1 plus 2. That means L to the power 3. Then T to the power minus 2. So this will be the dimension of gravitational constant. So in this way you can calculate the dimension. Okay. Now let's understand some basic things about dimension that you need to know, like how we will calculate dimension of any quantity which is inside of any trigonometric ratios or log functions or exponential function. See, if I write y equal to sine something, sine of something, y equal to log of something, y equal to e to the power something. See, sine of something will be a number, log of something will be a number, and e to the power something will be the number. So you know that dimension, number is dimensionless, right? You can't, there's no dimension for number. So that's why sine of anything will be dimensionless, and anything which is inside of sine will also be dimensionless. Why? Because sine is nothing but a ratio of two numbers, or it is an angle. So angle is dimensionless. That's why anything which is inside of sine function or any trigonometric function or which is inside of any log function, any exponential function will also be dimensionless. So from here you can calculate dimension of any quantity which is inside of sine function or any log function or any exponential function. Let's understand by example. If we have y equal to sine a x square plus b t, right? Here we have to, here x is distance, x is distance and t is time, and we have to calculate dimension of a equal to what and dimension of b equal to what. So how we will calculate this? Now let's understand. I have just told you that dimension of anything which is inside of any trigonometric function will be dimensionless. That means it is 1. So we can write it as a x square plus b t equal to 1, right? Now a and x is what? X is length, that means L square plus b into t is what? Time, t equal to 1. See, before this you need to know one basic things. You can, if we have to add x plus y or x minus y, suppose x plus y equal to c and x plus y equal to d. Now you can add only those quantity which has similar dimension. It means dimension of x and dimension of y will be the same, as well as dimension of c will also be same. Same manner, dimension of x and dimension of y will be equal to dimension of d, and dimension of x and y will also be the same. it means you can only add those quantity which has similar dimension or subtract which has similar dimension. You can't add or subtract quantity which has different dimension. We can only add those physical quantity which has similar dimension. In general, you can't add you know ghora to gadha, right? If we say in general language, so you can't compare two different things. You have to compare with similar characteristics. So that's why in physics we say we can add or subtract only those quantity which has similar dimension or similar unit. So that's why see here al square plus b into t equal to 1. Now from here you can understand that dimension of al square, dimension d of al square equal to dimension d of bt, right? Means dimension of these two will be the same. Now let's consider b's distance. B is distance. That means dimension of a al square equal to b is what? Distance. So b into t, that means l into t. L into t, right? So from here you can write it as a l square equal to l t. That means a equal to l upon l square into t. This becomes l to the power minus 1 into t. So in this way we can calculate dimension of any equation or any unknown quantity which is inside of any trigonometric function or any log function or any exponential function. Now let's consider some other example. Y equal to log ax square plus c or let's consider here y is okay, so let's consider y equal to log ax square. Here you have to calculate dimension of a. So I told you earlier that dimension of anything which is inside of any log function will be dimensionless. That means ax square equal to 1, right? And here x is what? X is distance. So from here you can write it as a into l square equal to 1. So this will be equal to a equal to 1 upon l square. That means l to the power minus 2. This is the dimension of a. So this is the way to calculate dimension of any quantity, any unknown quantity which is inside of any log function. So this way you can calculate from log function, exponential function, trigonometric ratios, right? Now let's consider some other examples. See, y equal to ax upon bt plus c. Here y is distance, y, x is distance, and t is time. Now you have to calculate dimension of A and dimension of B. Okay, so how we will calculate dimension of A and dimension of B? See, y is what? Y is distance. That means dimension of this will be L. So dimension of, what is the dimension of left hand side? Whatever will be the dimension of left hand side will be equal to the dimension of right hand side, right? I have told you earlier that whenever we do any mathematical things with quantity, then dimension of both side will be the same. Dimension of left hand side will be equal to the dimension of right hand side. So from that we can say that if y is the distance, that means the dimension of y will be the length L. So for that reason dimension of right hand side will also be L, right? That means dimension of ax will also be L, and dimension of bt plus c will also be L. Then only this equation will be considered correct, right? So if dimension of ax equal to L, so x is what? Length. So a into L equal to L. So here a equal to L upon L, that means 1. So a becomes 1, that means a is dimensionless. Okay, now let's calculate dimension of bt plus c. bt plus c. So we have understood that dimension of bt and dimension of c will be the same, right? And we have also understood that dimension of bt and dimension of c will be the dimension of left hand side, that is L, right? So from here we can say that dimension of c will be L, and dimension of b, how we can calculate? B into t equal to L. So dimension of b will be L t to the power minus 1. So this is the way to calculate dimension of any quantity, right? You can calculate dimension of any quantity by this formula. Okay, there are some question which has been asked in recent JEE mains on this topic. So let's consider some JEE questions which has been asked recently. See, we will see later in later class. We will see it in later classes. Before that, we will understand what is the importance of dimension. We have understood that how we can calculate dimension of any physical quantity, right? Now we will understand what is its importance, why we need to understand about dimension. So see, dimension is the way to represent physical quantity. I have told you this in earlier classes and 2D class as well. Now see, dimension helps us dimension help us to find correctness of any equation or formula. How? See, if we have to we know that F equal to mass into acceleration, right? We understand that if we write F equal to half ma, then also the dimension will be the same, because we know that dimension of number is nothing, it is dimensionless. So see, when dimension of left hand side and dimension of right hand side will be equal, then we can say that equation can be true or can be correct. But when dimension of left hand side and dimension of right hand side is not equal, then equation must be incorrect. What I have told? I have told you that when dimension of dimension of left hand side equal to dimension of right hand side, then our equation can be correct, but when dimension of left hand side and dimension of right hand side is not correct, matlab means not equal, then our equation must be incorrect. So if you have to find correctness of any equation, then first you need to calculate dimension of left hand side and dimension of right hand side. If the dimension of both side is same, then you can say that equation might be correct. But when dimension is not equal, when dimension of left hand side and dimension of right hand side is not equal, then that is 100% incorrect equation, right? So this is the way to find genuineness or correctness of equation. Okay, so see, we know that kinetic energy equal to half mv square. So from here dimension of this will be m l square t to the power minus 2, and we know that number is dimensionless, so there will be no any dimension for 1 by 2. Now if we write kinetic energy equal to 1 by 4 mv square, then also the dimension of this equation will be m l square t to the power minus 2. See, here you can see dimension of this two equation is same, but second equation is incorrect because kinetic energy equal to half mv square. So here you can say that by just checking dimension, you can't say that equation is correct, right? We have understood that, hope, right? Now let's understand how we can say that any equation is correct or incorrect on the basis of dimension. Let me consider some other examples. if b equal to u plus at, we know that b equal to u plus at, right? So b is what? B is velocity. That means dimension of velocity is L t to the power minus 1, right? And we know that when we add A plus B equal to something C, then dimension of these three will be the same. So that's why dimension of this U will be also L t to the power minus 1. And dimension of at will also be L t to the power minus 1. And u is what? In b equal to u plus at, b is final velocity and u is initial velocity. So that's why we can also say that, well, dimension of u is L t to the power minus 1. And a is what? A is acceleration, that means L t to the power minus 2 into time, that means t. So this also becomes L t to the power minus 1 plus L t to the power minus 1. And this is L t to the power minus 1 as well. So here you can see that dimension of left hand side and dimension of right hand side are equal. So that's why this equation can be considered correct. And you know that this is correct equation. You have studied about this in class 9th, right? Now if I write this equation as b equal to half u plus 1 by 4 at square, then also dimension of these two sides, left hand side and dimension of right hand side, will be the same, right? But you know that this is not the correct equation, this is incorrect equation. So that's why whenever we have to calculate, we have to find correctness of equation, we will say that we will first calculate dimension of left hand side and dimension of right hand side. When dimension of left hand side and right hand side are not equal, we will 100% say that this is incorrect equation. But when dimension is same on left hand side and on right hand side, then we can say that equation can be correct, right? So this is the way to find correctness of equation. Okay, so this is all for today. In next class we will solve some numericals which has been asked in recent exams. Then we will study about approximation. Okay, and this way our unit and dimension will be complete. So thank you all for watching this. Hope you enjoy the show. Bye bye, good night, take care.